Okay, great. Hi. Hello, everybody. Welcome to the NANOG afternoon tutorial session. This is the SP Security Primer, or Primer 101. If you're looking for Phil Smith's BGP Primer, that's in another room. My name is Roland Dobbins. I work for Cisco Systems on SP and large network security solutions. My colleague Barry Greene was going to be giving this talk today, but Barry couldn't make it, so I'm doing my best to fill in his stead. I do work for Cisco as a vendor. However, I have an operational background. I spent 4 of my 5 years at Cisco operating AS109, which is Cisco's network, including the network connectivity for CCO, or as we call it these days, Cisco.com. Cisco is an enterprise, but it's also a large SP-like enterprise, and it's a content provider. Because of www.cisco.com, we have iOS images, we have documentation. We're also an e-commerce shop. Prior to that, I spent several years working for an ASP, doing a lot of credit card processing stuff, again, handling operational security. Prior to that, I worked for Bell Atlantic. So the idea here is to go through and spend some time today talking about tools and techniques that we can use to enhance the security of the service provider network. And we want to be able to use tools and techniques that don't require us to go out and buy a bunch of new stuff. Rather, what we want to do is to leverage the existing network infrastructure that we have, do a little bit of OpEx, a little bit of elbow grease in order to make our lives that much easier. This presentation has been made available. It's downloadable from the NANOG website. The version that you will download says 1.3. The only difference between the 1.3 and the 1.5 that we're using right now is a couple of typos were fixed, and the updated version will be posted. It'll also be posted in PDF format and in editable PowerPoint, because the idea is that you can actually take this presentation back and use it for your own purposes within your organization to do train-the-trainer types of things and those kinds of applications. So, what's our goal today? Our goal this afternoon is to go through 10 basic techniques that basically any SP can do to enhance the security of the network and make the network more resilient, and also make your lives a little bit easier when you're faced with security incidents. This is very much a technology-neutral presentation. We're going to be talking about things that will work on basically any modern router vendor's equipment. And each of these techniques are proven. This is not theoretical stuff. It's stuff that people have done in real life, and it's proven to work over and over and over again. So, when we have a security incident, I think we've all been faced with this kind of situation at one time or another, where we have a DOS attack that gets launched against one of our customers, and the customer gets taken out. The customer's CPE router gets taken out, and our own SP network infrastructure, like our customer aggregation router, for example, gets affected as well. It's kind of an embarrassing situation, and it's not something that you really want to have to explain to management. So what we're going to talk about today is some tools and techniques that will hopefully allow us to lessen the risk of this kind of scenario, so that we can sleep at night, and if we get woken up in the middle of the night, that we can deal with security incidents quickly and effectively, so that we don't have to spend a whole lot of time handling these things. We have multiple threats. We obviously have the botnet threat, which is the big one, where we have tens of thousands, hundreds of thousands, and in some cases, up to 1 million bots. They're members of a botnet. They're used to launch outbound DOS attacks. Sometimes we see spoof traffic. A lot of the time we don't see spoof traffic. We just see lots of traffic. We also see worms that have, they're poorly written, actually, and that have DOS-like side effects that are a result of their aggressive propagation mechanisms. These things can take out the service provider infrastructure. They can take out the client. And, of course, they impact our SLAs and therefore our revenue. Not something that we want to have to deal with. We have an ongoing series of very security-related talks that we do here at NANOG, and you can get more of this type of material from the URL there on your screen off the nanog.org website. So, top 10 list. We have 10 things that any SP can do. I've done these myself. Actually, I've done 9 of the 10 things. I'll leave it to you to try to guess which one I haven't done, and we'll see who's figured that out by the end of the presentation. But the idea is to go through this list and not to try to pick all of these things and go back all fired up and try to do them all at once. Because if you try to do everything at once, you're not going to get anything accomplished. Instead, what we want to do is touch on the important aspects of each of these 10 things we can do, and then take that knowledge back home, and then pick one and start working on it iteratively. So we don't want to try to boil the ocean, right? So the first topic here is preparing your NOC. Every service provider needs a NOC. whether it's an actual room where you do shifts in the NOC and you have your various monitoring and provisioning equipment and software set up, or if it's even a virtual NOC where you have tools that are available where you can SSH in or VPN in and get to them, you need to have a NOC set up. Anybody who's worked in a NOC generally has some pretty definite opinions about what constitutes a NOC and what tools are needed in a NOC. So sit down, think about it, make a wish list. Talk to a colleague, get your colleague's wish list, and then try to make it happen. And again, we're not talking about going to management and asking for a big space-age Star Trek-like facility. That would be cool. But we can, by making use of open source tools and making use of things that we have lying around, we can actually build a pretty good NOC and not have to spend a lot of money. And that's really important. No NOC is perfect. There's always going to be room for improvement, and as personnel turnover happens, we have different folks with different skill sets. The needs of the customer base change over time, so the NOC is always going to be an evolving kind of thing. It's not static. So, what is an OPSEC team? Every service provider should also have an operational security or an OPSEC team. Some SPs have dedicated OPSEC personnel. For others, the OPSEC personnel are actually a subset of the escalation team. Sometimes they're embedded with the NOC staff as well. It's really important, though, that there is a designated OPSEC team which has not only the responsibility, but the authority and the empowerment to do something about security incidents when they take place on the network. It's very important that these folks are identified and that all of the major areas of the service provider are covered. Everything from backbone engineering to BGP specialists, IGP specialists, et cetera, et cetera. So, what do SPs need to do? Well, the first thing they need to do is they need to come up with a security policy. It needs to be well thought out, with input from a lot of different areas of the service provider, and it needs to be articulated, and it needs to be written down somewhere. Once we have a good security policy defined, we then get the resources that we need to implement that security policy. Sometimes that can take the form of firewalls. It can take the form of encrypting various types of control plane traffic that we haven't encrypted before. Authentication, audit systems. We need to be able to monitor the network and see what's happening on the network. We need to have the ability to respond when bad things happen on the network that we need to do something about. We need to practice. That's really key. We don't want the first run of our OPSEC team and the first experience that our NOC has figuring out how to deal with security incidents to be a live incident. Instead, we need to train, we need to prepare, we need to try to extrapolate realistic scenarios and come up with playlists as to how we're going to deal with them. Again, we can't ever be 100% sure that we're going to cover every contingency, but we try and cover as many as possible. And of course, when we deal with security incidents, we want to take that knowledge back and incorporate it into our playbook so that we'll have that experience for everybody else to share the next time something bad happens. Postmortems are really, really important. Root cause analyses are really, really important. A lot of people don't want to invest the time to do this, but it really pays off. So I strongly urge you to incorporate that into your mix as well. So, the preparation problems. A lot of SPs don't really have NOCs. They don't have well-defined OPSEC teams. They don't have procedures written down anywhere. They don't have communications plans. And so, when a security incident takes place, it's a mad scramble, rushing around trying to figure out what's happening and then what you're going to do about it. How many people have been in that situation before? Few honest folks here, okay, I know I have, and it's not a pleasant place to be. So what we want to do is to emphasize that it's really important to take the time to do these things up front because it will really pay off for you and for your customers moving forward. We developed a 6-phase incident response methodology that has proven to be pretty effective. Most people work through most of these phases anyway, but sometimes it's a good idea to actually write it down and identify some of the various components of each step. It gives us a way to think about handling security incidents. It also gives us a way to describe things to management and to explain to management what it is that we're doing and why. So, 6 phases. Preparation. This is where we get our tools, our techniques, our OPSEC teams defined, our areas of responsibility, our communications plans, and get all that stuff in place so that we're ready whenever an incident takes place. Next phase is detection, identification. Finding out that something bad is happening that we need to do something about. Oftentimes, detection consists of the customer calling up and saying, help, the internet's down. You got to do something to save me. That still is a very common detection mechanism. It's effective, it works, but we'd like to be a little bit more proactive if we can with tools and telemetry and so forth. So once we've detected or identified that something's taking place, the next step is to classify it. What is taking place and what is the scope of the threat? Is it a customer that's being threatened? Is it multiple customers? Is it the service provider infrastructure itself? This informs the next step, which is traceback. Figuring out where the bad stuff is coming from. Where is it ingressing the network? Is it coming from a peer? Is it coming from an upstream or a downstream? Is it coming from a cracked box in the IDC? So where is the bad stuff coming into the network from? Once we figured out where the bad stuff is coming from, we want to react. We want to react and mitigate the attack, stop the bad stuff from happening. And it's really key that we have enough visibility into the network and we have well-defined procedures so that during the reaction phase, we don't make a mistake and actually make the problem worse than it really is. That happens pretty frequently with SPs that are not prepared to deal with security incidents and have to figure it out on the fly each time. And now the sixth step, which in many ways is almost the most important step, but again a step that a lot of people skip, the post-mortem. Excuse me. During the post-mortem phase, we need to sit down and take a look at how we handled the incident. What did we do well? What could we do better? And then take that knowledge and put that back into the sixth phase process so that we, in our preparation phase, so that we're ready to deal with the next incident. Mitigation communities. We're not talking about BGP communities here. What we're talking about are communities of interest. There are lots of different communities of interest that it's really important that service providers are members of and that they're aware of because they can really help us when we're dealing with a security event. Oftentimes, security events, of course, are not constrained just to one service provider. They can be big network-wide events like Slammer. They can be distributed denial of service attacks, and DDoS can, of course, almost by definition, has to emanate from multiple places on the internet, right? So it's important that we understand what these various communities of interest are and how they can help during a security incident. So here are some of the communities. We kind of laid them out here. This is not really intended to show the relationships between them, but some of the big ones. NSP SEC is a forum that was started a few years ago, and it's taken off really well. And we have NSP SEC Japan, NSP SEC Brazil. We have the NSP SEC Discuss list, which is not for operational matters, but a lot of folks who are involved in operational matters, as well as security researchers and vendors and other folks are present on that list to talk about various aspects of operational security. And we're working right now on establishing NSP SEC for Korea, NSP SEC for Taiwan, and NSP SEC for China. We have Lawrence Baldwin's MyNet Watchman community. Gadi Evren over in Israel has formed the Drone Armies MWP and the FunSec list. And the idea for those is to really, he's following a lot of phishers and botnet herders. They're the first in CERT teams. There's DSHIELD.org, which is affiliated with the Internet Storm Center and SANS. Then there are the telecoms ISACs and the other ISACs as well. So there are a lot of different communities of interest that we should participate in and be aware of and know how to get a hold of when we need them. DSHIELD. How many people here are familiar with DSHIELD.org? Okay, a few. DSHIELD is a really cool resource. Basically with DSHIELD, you can take logs from various types of devices. Routers, firewalls, Unix machines, Windows machines, etc., and you can upload them to DSHIELD.org. And you can these logs that are collected are logs of security incidents. And by pulling them into DSHIELD.org, they then are pulled into a big analysis pile. And the data is shared with everybody else so that we can look for trends, things like an uptick in a particular protocol or port, an uptick in probing certain types of applications. It's a really valuable community resource. It's funded and operated by ISC, and I really recommend that you participate in it. You can get started with it at home, just on your broadband connection. There are clients, like I said, for various types of operating systems, and it takes logs from many different types of network devices. So get started on your home broadband connection and contribute to this because it's kind of a macroscopic view of what's happening on the internet in terms of port scans, probes, and things like that. Pretty useful. NSP SEC. How many people here have heard of NSP SEC? Okay, a few. NSP SEC is a closed and vetted forum that consists of network operators, people who have the enable password and are responsible for an ASN and can do something when bad stuff happens. There's a lot of vetting that takes place, so the NSP SEC list is not open. NSP SEC is also a confidential forum. It's kind of like Fight Club. We don't talk. The first rule of Fight Club is we don't talk about Fight Club. First rule of NSP SEC is that we don't talk about the specifics of what goes on within NSP SEC. That confidentiality is really important, but we end up with large and small service providers around the world, as well as representatives from each of the major vendors on there, so that when DOS attacks happen, when worm outbreak happens, when there are security incidents that affect multiple providers, that there's an easy place to go for help. It's not perfect, but it certainly has proved to be a pretty effective communications mechanism. SQL Slammer was a good example of that, as how well it was handled by the big SPs. It's hosted, like so many other lists, Jared Mach of Verio hosts it on puck.net or .net. And go to that URL, and that takes you through the application process and that kind of thing. This is an example of some, and I don't know how well you can make that out. It looks like it's an awful line color. I apologize for that. This is an example of some of the email traffic that you see on the NSP SEC list. For example, I've been working an attack against this /32. We're seeing traffic coming in from these various service providers and this particular exchange point. It's hitting both of these /32s on TCP 53, appears to be sourced from this network. I've got it filtered, so it's not bothering my customer anymore, but it's still pummeling my routers. Could folks please take a look-see and do some traceback to see if you can push this all the way down to its source and remediate it? So that's just an example of the kind of email traffic that we see on the NSP SEC list. Very routine, mundane, operational, but it's effective and gets the job done. So, a day in the life of a service provider. Something bad is happening. We want to throw up blocks and stop the bad traffic from ingressing our network. We throw out the blocks. Then we use the NSP SEC community to work with other service providers so that they can continue to block the bad stuff, trace it back through their networks until, again, we get to the source of the attack and then stop it at the source. It's about trust. Inter-provider mitigation requires trust. You have to be able to trust that the folks on the other end of the phone, that the folks on the other end of the email list know what they're doing, that they're responsible, that they're going to react. They have to trust you to know that you're not yanking their chain, that you're providing accurate, timely reports of things that are happening so that their time isn't wasted. Again, it's very important for a lot of legal reasons as well as other reasons that this information doesn't get out and shared throughout the entire world. All applications for membership in NSP SEC are vetted, and you have to have at least 2 folks to vouch for you. There's a number of conditions that are laid out on the URL that was mentioned earlier. Also, all the list members are re-vetted every 6 months. So if folks change job functions and they're no longer operational, yet they failed to inform the moderators, or they forgot to or what have you, we at least find out then and move them off the list. The custom is with NSP SEC that if you change out of an operational job, that you do let folks know, and they will then take you off the list. So, NSP SEC's not perfect. It's an email list in a community. It's not the ultimate solution, but it has had a very positive impact on the overall security posture of the Internet as a whole. I urge you very strongly to check and see if your group, if your organization is a member of NSP SEC, if you're a service provider. If so, then you might need to talk to folks internally to see if you need to be on that list. Maybe you don't. Maybe it's already handled. If your service provider is not a member of NSP SEC, I strongly urge you to go through the application process, and let's work on getting you vouched for and on the list so that you can be part of this community. There are meetings associated with NSP SEC. In fact, we're having one, a BOF, after this tutorial session is over with, in the Gold Room, I believe. Danny McPherson from Arbor generally chairs the BOFs, and he's chairing this one. In EMEA, Hank Nussbacher holds the RIPE security BOF that's held at RIPE. And then in Asia-Pac, we also have security BOFs at Apricot. And Derek Tay and Dylan Greene from Juniper chair those. So CERT and FIRST. CERT, Computer Emergency Response Team. FIRST, Forum for Incident Reporting and Security Teams. It's a very important resource. It's important that service providers become members of the relevant CERTs and of the FIRST team. It's really important because it's, again, another confidential community where a lot of information sharing takes place, good way to learn who your peers are working for other service providers and for vendors. It's also really important for vendors to join the FIRST as well. That way, we have a forum in which hopefully inter-vendor cooperation can take place in dealing with large security incidents and issues which affect the internet as a whole. If you're not a member of FIRST, I strongly suggest that you go to the URL there and check it out. Definitely worth your time. It'll pay some dividends if your organization is a member of FIRST. So, moving on to our third thing, the INOC DBA phone system. So, the INOC DBA phone system, let's go ahead and skip a slide here. It's a little bit out of order. So essentially, when service providers are working attacks together, it's important that they be able to communicate. And yes, we have the NSP SEC email list, and again, Jared Mach maintains the canonical NOC operators list on puck.net, but sometimes it's really important to be able to pick up the phone and get somebody with clue at the other end of the phone. And that is the problem that the INOC DBA SIP phone system is intended to solve. Basically, the idea here is that we want to have kind of a backbone, right? A NOC hotline that you can pick up and very easily get a hold of the appropriate folks at other service providers to work incidents together, folks who have the enabled password and can do something about a security incident. So how do you get started with the INOC DBA system? Well, you need to get a SIP phone. There are lots of different hardware SIP phones around. You know, Cisco makes them. I think Linksys makes them. Lots of people make them. There are also soft phones as well that work for different operating systems, for Windows, OS X, Linux, etc. So you just need a SIP-capable phone, and then you need to sign up at the URL there. Packet Clearinghouse operates the INOC DBA. Bill Woodcock, a lot of you know him. It's kind of the head guy there. And then find a couple of peers on that list and check it out. INOC DBA stands for Internoc Dial by ASN. So the idea here is if you need to reach somebody at AS 109, for example, you pick up the phone and you could dial 109. And the phones would ring and you would get somebody who could deal with something having to do with AS 109. You can also have sub-extensions underneath an ASN. For example, Barry's phone number is 109 and then 100. So that's his extension under AS 109. Cisco sponsors it. If you have a hardware-based phone with a SIP image, great. If you have a soft phone, great. If you don't have a phone, we actually provide phones, 7960 phones with SIP images, and if you register and let the folks at Packet Clearinghouse know that you need a phone, they'll send you one. Not very hard to set up, actually. It's a pretty straightforward setup process, easy to get it going. Just takes a couple of minutes. This has proved invaluable and surprisingly resistant during SQL Slammer. When we had problems with networks going down, the system was resilient and it stayed up and people were actually able to use it. So it's proven to be surprisingly resilient. We've had some folks get large numbers of phones for their personnel. We even have people who carry their phones around with them to conferences like NANOC and plug them in so that they can be reached. And it's not used just for security incidents. Once it's there, you can use it for other types of inter-provider consultation as well. We want to make sure that the INOC DBA phone is not abused. You don't want to stick it somewhere in an area where you have a bunch of first-tier people working on it. You really want to make sure that the appropriate personnel are empowered to use the INOC DBA phone, and they know that when somebody calls, it's not going to be a customer or somebody who's clueless. It's hopefully going to be somebody with a clue who actually has an actual problem that needs to be solved. We've run into a couple of issues with folks who have IT departments that for some reason or another don't want to enable the fix-ups or the plugins to allow SIP through a firewall. If you run into that kind of problem, sometimes if you just go to your security, your enterprise network security people for your internal network, and you explain to them that this is a security tool that you need to be able to use in conjunction with your service provider colleagues, they'll go ahead and open up the firewall for you. If they can't, or if they won't, you can always take it at home and plug it in at home off your broadband connection. A lot of people do that because oftentimes they get called in the middle of the night anyway when something bad is happening. We've had a couple of broadband service providers who have actually gotten broadband connections pulled into their NOCs as if they were customers so that they could bypass the firewall and get the SIP traffic up and running. So be creative. There are some ways around it. You can, with a soft phone at home, if nothing else, participate in INOC DBA. Pretty important. So, point protection. It's very important that the network devices themselves are as secure as we can make them. We want to make sure that only authorized personnel can get into the devices to configure them. We want to control the kind of traffic that can reach out and touch our network infrastructure. And then we also want to be able to audit the configurations to make sure that no unauthorized changes have been made. That can sometimes be an indicator that something bad is happening. We need to perform a risk assessment on our own network. We need to look at every aspect of the network, from the backbone to the IDC to the NOC to any kind of remote access solution, whether it's SSH or VPN or what have you, and think about all the different threat vectors in each portion of the network, and then take the appropriate action to mitigate those threat vectors. So, very basic thing is make sure that we know that everybody in the world can't SSH, because we're all turned off Telnet, right? We're all using SSH. I know that. Clueful crowd here. So that everybody in the world can't just SSH into our routers. If we have an out-of-band management network, which we should, we want to make sure that the out-of-band management network is also secured, and that we use encrypted mechanisms to get into it, and that not everybody in the world can get into it. Very important. Again, use SSH whenever possible, so that way we reduce the risk of interception of password if there's a compromised device on the network somewhere that's capable of sniffing traffic. If we're using SSH, they won't be able to sniff our username and password and then get into the device. AAA, extremely important. Set up AAA so that we're not relying on local accounts on the devices themselves. Instead, we can centrally control access to the device, and in lots of implementations, we can even do per-command authorization so that we can restrict what various tiers of support personnel are able to do. Extremely important to be able to centrally manage our access policy for the network devices. Radius is not a good idea for AAA, for ISPs. Why is that? Well, we've gone to the trouble to use SSH clients, so we're encrypting our logins, our passwords, our enable passwords, those kinds of things. But if we use AAA, that stuff gets sent, with Radius for AAA, that stuff gets sent in the clear. So it's really important that we make use of a AAA method that encrypts the username and the password and other information that's sent between the AAA servers and the network devices themselves. One-time password is also a good idea. If you can get a one-time password system installed, it's another layer of protection. Again, nothing is perfect, but it raises the bar. It lets us know that at least at the time of login that it was an authorized network engineer logging into a device instead of potentially a miscreant or an attacker who sniffed a password and a username somewhere. Protecting the AAA infrastructure from being DOSed is really important as well. Can somebody tell me why an attacker might want to DOS AAA infrastructure? Anyone? Well, one reason is that besides having a AAA infrastructure, a lot of people go ahead and put in a local account on a router, on a switch, so that they can log in if the AAA infrastructure is down. We've seen attacks where attackers go after AAA infrastructure and they DOS it, and because the service provider has not secured control plane traffic access to the device itself, management plane access to the device itself, you will actually see an attacker going in there with SSH or Telnet and trying to brute force crack the local account, which, more times than it should be is Cisco. And so that's we see that happen fairly often, actually. So it's not something that's rare or theoretical. So it's really important that we protect that AAA infrastructure and we harden it just as we would any other part of the infrastructure as well. We can even put the AAA infrastructure behind a firewall and use stateful inspection on the firewall to further secure it from unauthorized access, and have firewall rules that limit access into the AAA infrastructure from the beginning, and then also limit the access from the AAA servers out only to the network devices that they need to provide authorization for. And then we need to distribute our AAA servers as well. We don't want to go to all the trouble of implementing AAA and then have it as a single point of failure on the network. So it's really important to have a distributed AAA infrastructure so that if we have a network partition type of event, we can still make use of AAA and log in, authenticate on the devices themselves, and also have a command history and the logs that we can go back later on if we need to for any particular reason to backtrack. TACACS Plus, there are open source implementations of TACACS Plus available. We have one on ftpeng.cisco.com. You can go and download it. There's also an extended TACACS++ server. It's a fresh meat project. You can go there and download that, stick it on a Linux box, FreeBSD box, Solaris box, what have you. And then Shrubbery.net also has some various modded versions of TACACS available for download as well. So again, you don't have to go and buy anything to do this. Just take a Linux box, FreeBSD box you have lying around, download the open source implementation, and get started. So, back in the old world, back in the old days, basically anybody could reach out and touch a router. They could ping it, they could telnet to it, they could SNMP query it, they could try to SSH into it, what have you. And what we would do is we would go ahead and implement things like our VTY ACLs and our SNMP ACLs and those kinds of things to restrict the access to the device. So I would be able to reach out and touch a router. I could generate SNMP traffic and send it, and it would make it all the way through the service provider network to one of the core routers. Then at that point, my SNMP GET query would be denied by an SNMP ACL. Well, that's great, except that should I really be able to send SNMP traffic to your routers from outside your network in the first place? I don't think so. What we want to do, instead of relying on the device self-protection, we want to actually filter out all the junk that we know should not be headed towards our network infrastructure from outside of our network. Let's just go ahead and stop that stuff at the ingress points to our network. Let's stop it at the peering edge. Let's stop it from our downstreams, from our upstreams. Let's stop it from our co-located boxes. Let's stop it from our customer access edge. It's really important that we do everything in our power to limit the amount of traffic that can reach out and touch the routers, because we can end up with accidental or deliberate DOSes if we rely solely on things like SNMP ACLs and VTY ACLs and things of that nature. And of course, one of the nice things about ACLs in general is that on higher end boxes you often have hardware acceleration, so that the ACL processing is taking place on an ASIC, and generally speaking that's going to provide you a far more robust kind of resistance to attack than letting things leak up to the process level with things like SNMP ACLs and VTY ACLs and things of that nature. Monitoring the config of the devices is also extremely important. Oftentimes the first indication that we could have if we were paying attention that an attack was taking place on our devices is that unauthorized commands start being executed on the routers, and those commands end up changing the config of the router. So it's really important that we go out and grab our configs of our devices on a regular basis and then audit them to ensure that the configs are conforming to our standards and that we don't have anybody who is unauthorized tinkering with our routers and our switches and our network infrastructure. There are some really cool tools to do this. One of the most popular ones is called Rancid, the really awesome new Cisco config differ, but it's not Cisco specific. You can use it for Junipers and other types of routers as well. There's also another tool called the RAT tool. It stands for Router Audit Toolkit, that not only will help you audit the configuration, but you can actually assign scores to different things like VTY ACLs and SNMP ACLs and BGP peer authentication and things like that, so that you can actually take these configs and run them through the RAT tool, and it will generate a security score to tell you how relatively secure each one of your routers is. Pretty useful tools. Again, these are open source tools. We don't have to spend any money. We just need to take some time, download them, and set them up, and start using them. So, protecting the edge. So again, the old world, what we would do is we would go ahead and secure each of our core routers individually. Every router was accessible from the outside. In the new world, we want to make use of filters to stop random traffic from coming in and touching our network infrastructure, unless it's something that we really, really need. So we want to basically erect a force shield around the core of the network. Generally speaking, there are very few reasons why you need to receive network traffic towards your routers. I mean, people need to be able to trace route through the network, that's fine, but unless it's a very special circumstance, people should not be able to send SNMP GETs to your routers. People should not be able to telnet to your routers. So we want to filter out all that garbage before it hits the routers and percolates up to the process level. There will be instances in which traffic does need to come in. For example, GRE tunnels, eBGP sessions, IPsec for managed VPN that you're doing for a customer, things like that. If we don't have a good handle on those things initially, we can use some various tools like classification ACLs to see what it is that's hitting our routers and look and make sure that it all seems to be legitimate, and then filter out the rest. Obviously, we need to understand what the address space is that's used in the core of the network so that we can perform this classification process. It's really important to summarize as much as possible, because the more we can summarize our address space and have a well-defined address space, the shorter and more manageable our ACLs are in general. So infrastructure ACLs, or IACLs as they're called. The idea is to permit only required protocols and then deny everything else headed towards the IP address space of the network infrastructure. We certainly want to go ahead and implement anti-spoofing here as well. One of the basics of anti-spoofing is we don't want to allow people to spoof our own addresses from outside and send that traffic into the network. That's a given. RFC 1918 space, we don't typically want to see that coming in from the outside world for obvious reasons. Multicast, same thing. And then RFC 3330 also has a list of some additional special use networks that you typically are not going to see traffic headed towards or originating from on the internet. Fragmented packets. This is an interesting subject. So a lot of folks go through all the trouble of doing a classification ACL or using NetFlow or some other techniques to identify the traffic that's supposed to head to their routers and then block everything else out, but they don't think about fragmented traffic. And that's really an important concept because with on a lot of vendors' platforms, fragments are handled specifically in the access control list, and there's a fragments keyword that goes along with it. I'm not going to get into a discussion of this right now because we have a lot of material to cover in a relatively short period of time, but if you have questions about this afterwards, we can talk about it if we have time for Q&A. Otherwise, we can talk about it during the NSP security offer. I'll also hang around afterwards. But the point is we need to take care of special case traffic. Fragments is one good example. Another good example is other protocols. Most of the traffic that we see is TCP, UDP, ICMP, right? But there's 255 actual valid IP protocol numbers, 0 through 254. You know, there are protocols like GRE, ESP, AH, those kinds of things. Again, a lot of folks go to the trouble of doing classification ACLs and using NetFlow and what have you and figuring out what should be headed to their routers, and they filter out all the TCP and UDP and ICMP-based traffic that should not be hitting their routers, but they don't think about the non-TCP, non-UDP, non-ICMP protocols. And so we've seen cases in which folks spend a lot of time and effort on their IACLs, got them up and deployed, but then an attacker turns around and uses something like IGMP just to send a flood of packets, and it goes right through those ACLs or those firewall rules, whatever you're using, just as if they weren't even there. So it's really important to think outside the box here and not just limit yourself to the classical kinds of traffic that we deal with on an ongoing basis, but think about all the various IP protocols and ensure that we only allow the ones to your infrastructure that need to get there from the sources that are legitimately allowed to originate that kind of traffic headed towards your core. So another important point is that once we've gone to all the trouble to develop this infrastructure ACL, we have to put the permit IP any at the end there, else we could have a problem when we went to deploy it. The IACL is deployed inbound on the Ingress interfaces coming into the network at all the various edges. Again, we want to filter out fragments as well as other rarer types of IP protocol traffic that we don't normally see but that has no business headed in towards our core. So what does it look like here when we have our infrastructure ACL deployed? Well, for example, we know that the loopback range is something that we don't want to let in. And so if we're seeing traffic that purports to originate from the loopback address range, we know that it's spoofed, and we're going to drop that traffic at our edge and not even let it in towards our core. So what if we have traffic coming from a legitimate source? You know, in other words, it doesn't appear to be spoofed, but it's headed towards one of our routers. Well, unless there's a legitimate reason for that traffic to head to our routers and be able to touch them, we should just go ahead and deny it and drop it at the edge. What's an example of traffic that we want to let in? Well, let's say that we have TCP 179 because we have a BGP session going with the customer. Well, obviously we want to allow the traffic bidirectionally through our IACLs so that the BGP session can come up and be maintained. Again, maybe we have an eBGP multi-hop set up for some reason. And again, we need to make sure that we poke holes through our infrastructure ACLs to allow that session through so that it doesn't get blocked when we deploy the IACLs. IP options are another special case. IP options provide control functions for certain types of IP traffic. The most famous instance of this is source routing. It's required also for RSVP. Options are typically not handled in hardware, even on ASIC-based platforms. And so what we want to make sure that we do is that we take a hard look at the use of options in our network, and various types of hardware from different vendors typically they have the capability, most vendors have the capability these days to filter out options or to just simply drop them or ignore them. So make use of those capabilities if your hardware has it. Make sure that you leave options on where you need it. For example, if you have RSVP deployed for some of your Quaz stuff. But the idea here is, again, we're just simply minimizing the amount of traffic that can reach out and touch the router, or the amount of transit traffic, in this case, that can cause stuff to bubble up to the process level and consume CPU on the router RP. We want to make sure that we don't bite off more than we can chew with IACLs. We want to do an iterative deployment, so we pick a very wide range of protocols initially that we're going to allow through, and then we slowly narrow it down by observation, and we get more and more and more granular as time goes on. That way we avoid making mistakes that could cause outages as we deploy our IACLs. Again, we're going to classify. We can use a classification ACL to start classifying the traffic headed towards our network infrastructure. We can use NetFlow telemetry to do it. We can sniff if we have a place in the network that's appropriate to sniff the traffic using TCP dumper, something like that. Flow level traffic generally is a little bit easier to manage for something like this, or a classification ACL. Now, something to remember here is as you go through this classification process, just because certain types of traffic shows up in the classification ACL, or it shows up in NetFlow, it doesn't necessarily mean that that traffic should in fact be headed towards your routers. So it's really important to take common sense here and take a look at the stuff and see if perhaps you're going ahead and catching some bad stuff as you go through the classification process. With ACLs, you can also use the log keyword to actually log the ACLs and send them off to a syslog server. Be advised, on certain platforms, certain types of equipment, this can cause CPU to go up because it has to actually, the device has to generate the syslog messages and send them out. So if you use ACL logging as part of your classification process, make sure you keep a good eye on it to ensure that it doesn't end up adversely affecting your router's performance. So once we've gone through the classification process, we've audited it, and we think we have a pretty good idea excuse me, of the type of traffic that actually should be headed towards our network infrastructure devices, we want to go ahead and deploy the IACLs. And it's very important that as we deploy the IACLs that we watch the ACL counters to see if we're getting lots and lots of hits. If we see a whole bunch of hits on something that we have decided to deny, for example, we might have missed something that's legitimate that needs to be headed towards the network infrastructure, or it could be that we're coming under attack as we deploy. Again, don't forget that IP any. How many people here have forgotten permit IP any at the end of an ACL before? A couple honest folks, okay. It's not pretty when we do it, so let's remember that at the end of the IACL we need that permit IP any so that we don't end up with that default deny. And now we have a very basic IACL. We've carved out a large swath of traffic that was headed to our routers. It's no longer pummeling them, and that's a good thing. We can rinse and repeat, and again, we start out at the macro level doing some basic protection. As we learn more about the network, we deploy more instrumentation, and have a better insight into our network traffic that's headed towards the core. We can then refine these ACLs even further and make them more granular. So again, we go through, we look at after we've filtered out the protocols at a macro level, we then look at source and destination IP address pairs, and we make that part of the next iteration of our ACL, where we actually restrict the source IP and destination IPs of certain ports and protocols. We go ahead and deploy that on our network. So once we deploy the IACLs, we essentially have that force shield erected around the core of our network. It's not perfect, but it certainly is beats having nothing at all. There may be some places where you can't deploy IACLs because of certain circumstances, because of hardware limitations, things of that nature. Always need to keep that in mind. It's very important to understand the capabilities of your hardware before you do something like this. You don't want to find out that a particular older piece of hardware that you have doesn't really like to run ACLs until you go and deploy it, and you end up causing a network outage. So it's really important to secure that. And again, once we've gone ahead and deployed our IACLs everywhere we can, what we want to do next is to try to work on securing the control and management planes of each router, each switch on the network. So, remote trigger black hole. Remotely triggered black hole filtering is a very useful reaction and mitigation tool. It allows us to very quickly drop traffic at the various edges of our network. And the nice thing about it is that we don't have to type conf t on our routers that are actually routing traffic. Instead, we can have a trigger router that uses BGP as a signaling mechanism to signal other routers to drop the traffic that's causing a problem, a DOS attack, traffic that's related to a worm outbreak, things of these natures. And of course, the nice thing about this too is that the drop happens at IBGP speeds, propagating across the network, so it's very quick. This is probably the #1 reaction and mitigation tool that SPs have at their disposal today. And again, it doesn't require buying anything. We just go ahead and leverage the routing infrastructure that we already have and the protocol we're already familiar with, BGP, to use it as a reaction and mitigation mechanism. So how does this work? So we see some bad traffic, we've identified it, that something bad is happening, and we want to block the traffic. So we have a trigger router. It could be a router. It could be a Linux workstation running Zebra or Quagga or something like that. And we actually go ahead and trigger a routing update that goes to all of our various edge routers and essentially advertises a specific route for that destination, a very specific route, so that all the traffic headed to the destination that's under attack gets sucked down into the bit bucket. That's a way that we can take pressure off the customer. Now, one thing to realize is that when we're doing destination-based remote trigger black holing, which is the most common form of remote trigger black holing, that we are, in effect, completing the DOS for the attacker. So that's something to consider as we do this. It's an important tool in the toolkit, but we need to understand the side effects of it as well. And of course, the bad traffic heads into the bit bucket once we've black holed it. And again, as we work that inter-provider mitigation that we were talking about earlier in the context of NSP SEC, remote trigger black hole filtering is the most common tool that service providers use when they're working a large attack in conjunction with other service providers as well. This is, again, a very common tool. It's proven. It works very well. We have some documentation on how to do it. And again, this is not Cisco specific. This works with just about any kind of router that speaks BGP. There is a variation of this called source-based remote trigger black hole routing. There's an anti-spoofing mechanism in Cisco land. We call it Anycast RPF. Other vendors have a similar type of mechanism. And on certain devices and platforms, you can actually combine the remote trigger black hole routing with the Unicast RPF functionality so that you can do source-based black holing, which is a really powerful tool because you're no longer completing the DOS for the attacker. Instead, you're able to actually block out the sources of an attack. Another thing to think about in terms of remote trigger black hole filtering is that you may want to whitelist certain address blocks, like, for example, your NOC. Or you might want to whitelist the root name servers and the TLD name servers and things like that, because you don't want an attacker to perhaps generate a spoofed attack coming from outside your network and fool you into black holing an important part of the internet infrastructure that your customers need in order to be able to make use of the internet. So moving right along, another one of the 10 things that we want to work on is sinkholes. How many people here are familiar with sinkholes? Okay, a few. So the idea behind a sinkhole is, again, we're going to leverage BGP. And this time, instead of taking the traffic and dropping it at the edges of our network, what we want to do is to take traffic that we're interested in and pull it to a designated portion of the network where we have some instrumentation set up. Maybe where we have an Armon probe set up, where we have a box running TCP dump, a box running NTOP, something like that. And so we can take that traffic and suck it across the network and pull it down into our sinkhole, and then we can analyze it and see if the traffic is bad traffic and if maybe we need to do some filtering or do something about it. We can also use sinkholes as a way to monitor attack noise and scans. We can take some unallocated address space and advertise it out of the black hole and essentially see what we suck in. And that's also pretty interesting to do that and log all of that stuff so that we can go back and analyze it. There was actually a pretty good tutorial a few nanogs ago on this. There's the URL for it. I recommend that you check that out, get the presentation, watch the VOD. Again, here's the basic premise here. 172.168.20.1 is being attacked. It's a /24. We have a sinkhole network over on the side there somewhere hanging off of our network. And what we do is we advertise a more specific route for the IP in question, which in this case was 172.168.20.1. We'll put a /32 route into our IBGP so that we have a more specific route and we can suck the traffic that was originally headed for the target of that attack into our sinkhole. And that way, again, we can take a look at it with our instrumentation, and if we've implemented a scrubbing center of some kind, we can maybe scrub the bad traffic and then re-inject the good traffic so the good traffic will head on back down to the victim. So again, when we advertise a default route in a service provider network, we can pull in all kinds of interesting stuff, again, scanning worms, malware that's looking to propagate. worms that sit there and chatter that go across the entire IP address range, like code red and NIMDA, things of that nature. So if you don't have a default in your network, putting default in the sinkhole can be pretty useful. Now, one thing you have to be careful with a sinkhole, however, is that you can suck down a lot of traffic really quickly. And sometimes this is bad traffic, maybe at very high rates of PPS. So when we use a sinkhole, we need to make sure that we're watching what's happening, that we understand the amount of traffic that we're pulling down, that we don't end up melting part of our network. And that's also something to consider if you use default in a sinkhole, because default route is default route. And if something bad starts happening, generating a lot of traffic headed towards non-existent net blocks, it's all going to be sucked down into that sinkhole that's running the default route. So you need to be careful about that. Another technique that we can use in conjunction with sinkholes to kind of lessen that danger of sucking down so much traffic is to Anycast the sinkholes. How many people here are familiar with Anycast, IPv4 Anycast? Okay, a few folks. So basically with IPv4 Anycast, what we do is we take an address block and we advertise that address block, that same address block, from multiple places within the network within our IGP. Okay, perhaps within our IBGP, we don't want to leak it out necessarily to the outside world. But the idea here is that we can build multiple sinkholes, all using the same address blocks in different portions of the network, so that if we have a large distributed attack come in, and we want to analyze that traffic, maybe we want to try to scrub it and send it back out, if we have that capability within our sinkholes, that we can simply send a single BGP advertisement, IBGP advertisement, or single IGP advertisement if we're doing it that way, and suck that traffic down into multiple places around the network, so we're not backhauling a lot of DOS traffic or a lot of worm traffic, and we can that way distribute the load and not run the risk of melting part of the network by pulling too much traffic down. Source address validation. At this stage in the game, year 2006, the 21st century, there's really not a valid reason for spoof traffic to be able to egress from your network and completely spoof traffic to ingress your network. We have enough capabilities now in hardware devices and in software that we have anti-spoofing technologies as basic as ACLs, as well as things like Unicast RPF, that we can really, if we put our minds to it, work to reduce the amount of spoof traffic on our network to practically zero. The original RFC for this, BCP 38, RFC 2827, there has been an update recently to this, BCP 84. The idea here, though, is to talk about ingress filtering, defeating DDoS, because at the time a lot of DOS attacks were spoofed, by employing anti-spoofing technologies. So, what is BCP 38? Essentially, what we want to do with BCP 38 is to ensure that spoof traffic cannot ingress the network. That's not just from our edges, from our peers, not just from our upstreams or our downstreams, but it's from our customers as well. We have a block, 96.0/19 or whatever, and then we have that block allocated, broken up into /24s for various customers. Well, each one of those customers should only be able to source traffic from his individual /24. There is no good reason for him to be able to send traffic that appears to originate from somebody else's /24. So it stands to reason that what we would want to do is go ahead and filter the traffic as it ingresses our core from the customer network, and only allow him to send traffic that purports to be from his assigned source addresses. With BCP 38, we want to filter as close to the edge as possible. We want to prevent potentially spoof traffic from ingressing the network. So at all of our various edges, again, our peering edge, our customer aggregation edge, our IDC, if we're a broadband provider, the broadband access edge, we want to filter traffic and filter out spoof traffic as close to the edges of our network as possible. If there are places in the network where we can filter both source and destination, we want to do that too. We want to be as tight with this as we can. There are lots of techniques to do this. The most basic one, again, is ACLs. Just about every kind of device that routes IP packets supports ACLs of one kind or another. If nothing else, we can use ACLs for our anti-spoofing mechanism. You can have, in many cases, dynamic access lists that are provisioned via AAA profiles. When a customer signs in, with Radius, for example, we can, pop an ACL dynamically down on the access device as first layer 3 hop. There's Unicast RPF, which is a very effective anti-spoofing mechanism. On the cable side of things, there's Cable Source Verify, Packet Cable Multimedia. And on the Metro East space, we also have IP source verify, as well as DHCP snooping on the Ethernet side as well. So all of the various types of access technologies have anti-spoofing mechanisms that we can implement today. They've been around for quite some time. It's really important to understand that we have to be conservative as service providers, right? We have to make sure that changes that we make don't break the network and don't make our customers want to go and buy service from somebody else. It's important that the service provider has operational confidence in the equipment, understands its capabilities. And what we found in talking to a lot of SPs is that the reason that they haven't implemented BCP 38 and they haven't really implemented aggressive anti-spoofing at all is because they lack operational confidence in the technology. They're not sure how it works. They're not sure how it's going to work on their older hardware, right? And so what we need to do is to gain the knowledge through testing and through piloting these technologies to figure out what works on our equipment and then move forward with it. So, how do we do this? Well, we don't rush out and turn on Unicast RPF everywhere. We may have line cards that will fall over if we do that. We may have older devices that simply can't do it. We may have devices that don't allow us to run ACLs on them, right? So instead of rushing out and trying to deploy BCP 38 throughout the entire network, what we want to do is to have a very phased iterative approach. So, the first phase here is to work with your vendor, Cisco, Juniper, whomever. Go into their labs, talk to them about it, find out what the capabilities are of the equipment, play with it in the lab. Then, once we have a good idea of what the equipment that we have is capable of doing, the next step is to pick a router and a port on a router. Do a pilot deployment there. See how well it works. Take the lessons learned and then replicate it. Next thing, we move up to a whole line card on a router with all the interfaces on that particular line card. Let that run for a while. Make sure it works okay. Let's do the whole router at that point. Once we let that stew for a while, it's good. We took some lessons learned. We then deploy it on multiple routers. And then once we have operational confidence in the various types of anti-spoofing technologies that we're using, we can then write it all up, a standard operating procedure, and put it into our standard configs and deploy it throughout the network. Again, you don't want to do this kind of thing as a flag day. You want to do a phased, iterative approach, and that's true of all the things that we're talking about today. So, it takes time and patience to do this. It doesn't work for everyone. Going slow and steady is a good idea. We've had several SPs who've done a good phased, iterative approach to this, taken about a year, and you end up with 40,000 ports. Running, Unicast RPF for anti-spoofing at the end. So it can work, and it does work, and it's something that we really strongly urge you to take a look at. So what can you do to help? Cut the excuses. Let's go ahead and get to it. Find ways to gain operational confidence. Again, it's really important that we have a good feel for how well the technology works on our equipment. Be patient. Be persistent. Don't expect instant success, but just do it steadily as you can with all the other things in your work queue. One day you'll wake up and you'll have anti-spoofing deployed throughout the entire network. Pretty nifty. So, control plane protection. This kind of goes along. It's the next logical iteration after we've done our IACLs, right? Once we've done our IACLs, we stopped all that garbage from coming in the network and reaching out and touching our core routers. The next thing that we want to be able to do is to secure our control plane. Sorry about that. There are some really good documents that have to do with securing BGP and various BGP attack vectors, for example. We have the URLs here on the screen and in the presentation. There are updates to these. We have some research that we've done at Cisco that we make publicly available as well. Team Cumbria do a lot of this kind of thing. You can go and find quite a bit of information on likely attack vectors for BGP and then some of the mechanisms for dealing with it. So, what are some ways that you can whack a BGP session and take it down? One thing you can do is try to saturate the receive path queues on the BGP speaking router. Saturate them, BGP times out, session goes down. We cause a DOS. We can try to just saturate the link, just fill the pipe up. We can try to mess with the TCP session itself, to drop the TCP session so that it's no longer cohesive, and we again cause a DOS that way. Or if we can affect the IGP and cause the IGP to drop, at that point we cause a recursive routing lookup failure, and BGP won't work either for iBGP. So all the normal attack vectors that people use to attack computers apply to routers. I mean, routers are, after all, computers, right? They're special purpose computers running a special purpose operating system, but they're computers. So social engineering, brute force attacks with passwords and usernames, DOS attacks, all those kinds of things can and will and are used to attack routers each and every day. What does an attacker need to be able to do to successfully attack a router? He needs to be able to get into the router itself, or he needs to be able to get into the network somehow to use that as a hopping off place for attacking the router or routers that he's really after. So, saturating the receive path queues. Most modern routers have various receive path queues in hardware or in software. If we saturate the device, we saturate those queues, again, we basically squeeze out the valid packets. We squeeze out the valid packets so that they can't communicate, and we have all this garbage filling up the queues and saturating it. Again, BGP times out, drops the BGP session. It causes a DOS because traffic can no longer be routed across the network. DOS attacks saturating the link will definitely knock out your various types of control plane packets. It doesn't matter if it's POS, ATM, Ethernet, what have you. If we can cause the link to drop, at that point that drops the next hop out of the fib, and again will cause the BGP entries to go away. It's a very effective brute force attack. We see it all the time. It used to be that we thought that dropping a TCP section, required an inordinately large number of packets to get the in order to send the TCP session down. We've learned that that's not necessarily the case. If we can successfully spoof and inject traffic into a TCP session and then send an RST or a SYN flag, which is RFC compliant behavior, we can cause the TCP session to reset. What do we have to do in order to do that? Well, we have to successfully match the source address of one side of the BGP conversation. We have to match the appropriate source port. We have to match the destination address, which is obvious, and the destination port, which is also obvious for BGP. And then we have to match the sequence number and get inside the window there. We've seen some attacks. Remember a couple of years ago, a guy named Paul Watson demonstrated that this was a little bit easier than had previously been thought. It doesn't require nearly as much traffic to try to make this happen. So it's something to be aware of. What are some ways that we can defend against this? Well, we certainly have our various methods that we already talked about, IACLs, anti-spoofing, things of that nature. But it still is possible in certain circumstances that folks could try something like this. So what's one way to deal with it? Well, the Generalized TTL Security Mechanism, GTSM, otherwise known as the TTL hack, is a cool hack that allows us to stop traffic from even talking to the BGP session. What we can do is we can configure a router so that when it generates the BGP packets, that they have a TTL of 255, and that they reject packets that have a TTL lower than 254 or 253. And of course, this makes sense if you think about it. If we have a normal BGP peering, obviously not an eBGP multi-hop peering, but we have an IBGP peering or a normal eBGP peering, we're not going to go more than 2 hops, right? It's, by definition. So what will happen in this case is if we go ahead and use the GTSM, which is supported, I think most modern router vendors support the GTSM, and we configure it this way, it doesn't matter if somebody can spoof the TCP session and even get in there and get within the sequence window of the sequence numbers, because we're going to drop that traffic before it even gets to TCP because of the TTL expiry. So it's a pretty cool little hack, actually. Another thing that we want to be able to do is secure our routing connections, right? So we want to authenticate our routing so that we know that this is an appropriately configured peer on the other side, that it is indeed under positive control of the people that we think it's under control of. So routing authentication is a good way to do this. The typical way that this is done with most routing vendors is MD5 peer authentication. There's also some good side effects of this besides the basic premise of authenticating your routing protocol relationships. It also allows us to stop malformed packets from tearing down a session, because the MD5 checksum is typically done on the TCP part, not just on the routing update. So it's actually a pretty effective mechanism in that regard. The one thing that this can't protect against, however, is that if somebody compromises a router that is set up properly, that has routing authentication and all this good stuff, if somebody compromises the router and then starts generating bogus routing updates, there's nothing that the authentication is going to do because the session is authenticated. So we still need to do all of our other things as well. Turning on the MD5 authentication is not a panacea. It raises the bar, and that's a good thing, but it's not the end-all, be-all of router security. So, another attack vector. attackers will often go up against the IGP. BGP, of course, depends on the IGP. I mean, we can have static hold-down routes at our edges, but if we want to get the traffic across our network to its ultimate destination, the IGP has to be in place as well. EIGRP and OSPF, of course, can potentially be DOSed in this way from outside the network if we're not doing appropriate IACL filtering, because they are dependent upon TCP/IP. IS, of course, is the big exception because it runs across CLNS. So, if we were going to attack the routing protocol itself, or use it as an attack mechanism, we could get in there. What would we want to do as an attacker? Well, one thing we might want to do is to suck the traffic somewhere in the network where maybe we have a compromised host that's in a position on the network topology where it can sniff traffic. So that we essentially create our own sinkhole, right? So that we can pull the traffic past and look for usernames and passwords and banking information, all kinds of good stuff. So that's one way to do it. Another way is to overclaim address space that we really don't have the authorization to route for in the first place, and essentially cause a DOS on somebody by advertising a portion of a net block with a longer, more specific prefix. Another way is to underclaim, so we actually go and we get rid of routing statements so that we're no longer advertising net blocks that we are supposed to be advertising for our customers. And again, we cause a DOS that way as well. So once an attacker can get into a router and manipulate the routing, there's a lot of different things that he can potentially do. So what is a prefix hijacking? First of all, how many people here have been victims of prefix hijacking in the past? A few people? Okay. Definitely something that's unpleasant to deal with. What happens is that somebody announces some address space that doesn't belong to him, and perhaps his peers, his upstreams, whomever, don't have route filtering in place, and so they will actually accept that advertisement, and sometimes this person might advertise a more specific chunk of the routing space, and so suck down traffic that's really intended for you, and it causes a big disturbance. It can oftentimes be very frustrating to deal with. Again, this is an instance in which being part of a community like NSP SEC has its advantages, because you can quickly get a hold of folks at other service providers who can, if nothing else, filter out these bogus routing advertisements until you can get hold of the people who are actually doing it. Lots of well-known instances of this happening. There was one that was discussed on the NANOG email list a couple of weeks ago, as I recall. So for malicious routing injection, what can service providers do? Well, certainly we can do ingress prefix filtering on our customers. If we have customers that are speaking BGP with us, we want to make sure that we use distribute list or prefix list or whatever the appropriate route filtering technology is, so that not only are we filtering out via ACLs their source addresses of their IP packets, but we also want to filter out a routing advertisement so that they can't accidentally fat finger something and send out a bogus routing advertisement and end up hijacking somebody else's space. Definitely something that we need to be able to do. Where would we want to prefix filter? Well, we certainly would want to prefix filter bogon space and unallocated space advertisements coming in from our peers, from our upstreams, and from our downstreams. Why is this? Well, people will either they'll fat finger something and they'll send a bogus routing advertisement for unallocated space. You can say, well, what's the big deal? There's no harm, no foul. That net block has not been allocated yet. Well, that's true, but oftentimes spammers use this as a technique. They'll actually go and identify a net block that's not been allocated yet, and if they have managed to crack a router at a service provider that does not do good egress filtering and it has some peers who are not doing good ingress route filtering, they'll actually advertise an unallocated net block and then send a whole bunch of spam from it for a while, and then they'll withdraw the route, and so it makes it hard to find them. This is a technique that we see used fairly often. So it's very important that we prefix filter at all of the edges of our network with as much specificity as possible, so that we are not accepting obvious bogon routes, that we're not accepting obviously unallocated routes for unallocated net blocks, and we certainly don't want to be able to accept somebody else's routing advertisements from our customers. Now, there are always exceptions to this. of course, but generally speaking, these are the principles that we want to follow. Again, we have bogons and special use addresses. IANA maintains, they are the canonical authority for allocated net blocks. There's the URL where you can go and check. Team Cumbry also carries a nice set of filters that are based around these, and every time a new net block is peeled off and allocated, those example filter templates are updated. We also have special use addresses that are intended for special use. Things like 127.0.0.1, which is a loopback, the test network 192.0.2/24. Again, these are things in the normal course of events that you just don't see advertised across the internet. Prefix filtering. So we definitely want to apply prefix filtering to all of our eBGP neighbors, to and from our customers, to and from our peers, to and from our upstreams, to and from our downstreams. Kind of a given. So, total visibility. So we've talked about all these different things that we can do to join communities. We've talked about ways to harden our network infrastructure. We've talked about ways to try to secure our control plane infrastructure so that we don't accept bogus routing updates and things of that nature. Now what we want to do is extend our visibility in the network and really get an eye for what's happening on the network. If we understand what's normal for our network and what's normal for our customers' networks, we then have a better chance of proactively detecting when something abnormal and potentially bad is happening so that we can figure out what to do about it. SNMP, very basic kind of telemetry that's available. Just about every device on the planet supports SNMP with various MIBs and capabilities. Having an SNMP monitoring infrastructure is something that's extremely important. You can use it to monitor CPU. You can use it to monitor available memory. You can use it to pull routing table dumps. You can use it to pull configs for auditing, all kinds of interesting things. And of course, again, there are a lot of open source tools out there to allow us to use SNMP so we don't have to go and buy a lot of expensive hardware and software. Armon. How many folks here have Armon probes or use them? Anybody? One person? Okay. So Armon probes are useful if you have a place in the network where you can do port replication and sniff traffic. Armon probes are a great way to characterize traffic passing through that particular point on the network. There are commercial Armon probes, but again, there's software like NTOP that allows us to do Armon using open source software. Again, it doesn't cost us any money. We just find an old box lying around somewhere, put one extra free BSD on it, and there we go. We also have a lot of links in the addendum at the end of this presentation that tell us about more SNMP, Armon, and other types of tools that we use. The real key here when we're talking about listening to the network is that we have all these various types of telemetry in the network. We have the routing table, we have flow information, we have syslog, we have Armon, we have the ability to sniff packets and those kinds of things. And just like the new holistic medicine approaches that doctors tend to take, we want to make use of all of these various types of telemetry so that we understand the health of the network as a whole. It's really important. And the information is there. That's the thing, is we're actually leveraging the network itself if we do this. So the information is all there. We just simply have to be able to collect it and analyze it and then operationalize our use of that information. So there's a lot of open source tools out there that allow us to make use of NetFlow telemetry. How many people here are familiar with NetFlow? Okay. How many people here actually use NetFlow? Okay. Good number. So NetFlow is a form of telemetry that is generated by routers that provides descriptions of traffic headed through those routers as well as traffic to those routers. Cisco originally came out with NetFlow. A lot of other vendors have implemented it. Juniper had an implementation. I think there's the SFlow project that a couple of vendors support, and now there's an actual standard for flow-based telemetry, an IETF standard called IPFix that all the vendors are working to converge on, so that you can have a common set of tools analyzing flow telemetry from different vendors. There's a lot of open source tools out there that allow us to do traffic characterization with NetFlow. Here's an oldie but a goodie flow scan, and we're taking a look here at a traffic dump from the University of Wisconsin. It's based on NetFlow analysis. And so we see a real drop in traffic, and we have an annotation down there at the bottom that's saying, hey, we had an outage and here's why. Then we see a spike in traffic as well, and so we can go back and investigate that and see if that's an incident that maybe we need to take a closer look at. There's a great NetFlow analysis system called Stager. Again, this is open source software. It's a web-based system. It has a Postgres backend. It makes use of the OSU Flow Tools, which is an open source NetFlow collection suite, to suck in NetFlow telemetry from various types of routers. And it sticks them in the Postgres database. And it has a nice web interface. You can run all kinds of reports, packets per second, bits per second, what types of traffic you're seeing, how much. It'll do graphs. Very useful for traffic engineering purposes as well as for security purposes. There are other types of data visualization that we can do. The RRD tool library is pretty useful for this in conjunction with tools like MRTG and other types of telemetry analysis systems. Here we have some good examples. One of them that's very interesting is the graph on the upper left here. That's actually a graph of DNS queries per second, and it's broken down by record type. And you can see that there's a real spike in MX record queries there at a certain point in time. A real spike in MX record queries like that stands out might be indicative that maybe one of our customers has been compromised and his box is being used as a spam proxy, right? So there's a lot of different inferences that we can make from the various sources of telemetry available on the network if we're simply willing to spend the time and effort to deploy the tools to make use of it. Again, we're seeing some traffic spikes. This black graph on the right shows both inbound and outbound traffic. The outbound is on the positive axis. The inbound traffic is on the negative axis. And again, we see the spike right there of throughput. We're doing some latency monitoring there on the bottom right. And then we see a spike in round-trip time latency. Again, this can be something to look at. Perhaps we're undergoing a DOS attack or some other kind of problem that might be security-related that we need to investigate. Armon, again, very useful tool. NTOP, nice open source. Armon probe, ntop.org is where you get it. Has a nice web interface, and of course, Armon is actually looking at the packets themselves and can give us information like TTL, for example, and other very detailed information out of the packet header as well as the payload. And then, of course, we have our routing protocols. Monitoring our routing protocols for spikes, for drops, and things like that can be pretty useful. And, of course, here is a canonical example of SQL Slammer. We see at the time the global routing table was about 128K, and then with all the disruption caused by SQL Slammer as various devices went down due to just the overwhelming amounts of traffic, we saw all these BGP speaking routers go down, and then the number of prefixes just plunges, down below 124K. Then we see a recovery cycle there. So again, this is a way to infer the global impact of an event like SQL Slammer. That's one way to do it, is to look at its effect on the global routing table, which of course directly impacts reachability. Taking NetFlow and routing data and putting them together, we can do all kinds of sophisticated peering analysis to make sure we're peering with the right folks, to make sure that our traffic ratios are being honored and that kind of thing, as well as do billing for customers, etc. And it's always a good idea when we're looking at these different forms of data, if we see something that looks weird with one source of data, like NetFlow or like BGP, that we then go to another form of telemetry, another source of information, to see if this is just an anomaly that affects one particular portion of the network, or if we're seeing the effects ripple through the network. And that's generally when we see a confirmation from two very different types of telemetry, like NetFlow telemetry and routing telemetry, that something is happening. That's a pretty good indicator that it's not a false positive, that, hey, there's something here that we really need to investigate and take a look at. Syslog, of course, an oldie but a goodie. This is the de facto standard for logging information across every kind of device imaginable: routers, firewalls, IDS systems, load balancers, you name it. Can generate syslog messages. We talked before about the fact that on certain platforms we need to be careful if we're going to log ACLs so that we don't overwhelm the CPU of the router. One of the nice things about syslog is that it's a UDP-based service, and so we can use an Anycast addressing technique to actually distribute our syslog infrastructure throughout our SP network, and then have our devices configured to export syslog just to one or two addresses, and then they'll just simply, via the magic of Anycast, go to the nearest syslog instantiation and log the data. If we're doing that kind of distributed syslog collection, it's really important that we have some kind of back-end database that we ultimately dump all the syslog syslog information into so that we can go through and correlate it and put it all together. A lot of folks use MySQL, Postgres, some of the various open source databases to simply log the syslog information and go back and do queries on it. Syslog has a concept of facility numbers so that we can actually, on most devices that generate syslog, we can specify the facility number that they generate in case we want to segregate our log files out that way on our collection systems. Syslog NG is a newer form of syslog that's available from balabit.com. It's open source, and there's a good how-to on syslog NG and some of its functionality located at campin.net at that URL. NTP. NTP is often an overlooked network service, but it's really critical. Why is that? Well, for one thing, if we're processing lots of syslog information, for example, if we're processing NetFlow telemetry, if we're processing any kind of information from the network, we need to be able to ensure that the timestamps marry up so that we can do our auditing and our analysis. Otherwise, we don't really have a good idea if we're seeing a widespread event on a network or that something real is happening. It's valuable for auditing purposes as well. We're syslogging our routers, and people log into the routers and there are config changes made, and maybe something gets broken or something suspicious is happening. We want to be able to go back through our logs and audit them to see who made what change where and at what time it was made. So deploying NTP across the network is really, really important for a number of reasons. There's also an NTP MIB that's actually available where you can grab time information from the routers via SNMP. And there's actually some work going on. Folks are trying to figure out if we can detect if bad things are happening on the network by looking at time skew and NTP jitter. It's very interesting. It's early days yet. Some folks have some ideas about it and are taking a look at it. So NTP is something that I think you all probably have deployed on your network. Raise your hands if you have NTP deployed. A lot of people. Okay, some of you who don't need to go ahead and get it done so that all your logs are in sync and you don't have any uncertainty when you go back to audit or you're trying to correlate. And of course, sometimes there's no substitute for just looking at the packets themselves. We don't typically start analyzing an event by looking at packets. We generally have some macro level indicator like NetFlow or routing protocol or SNMP, CPU spike on a router, something of that nature. But once we've identified that something is taking place, sometimes we just need to get in there and capture the packets and take a look at them and see what's going on. A lot of information, obviously, all 7 layers of the OSA model are represented with the packet capture. This particular screenshot is of Ethereal, which is a nice open source protocol analyzer available from ethereal.com. It's multi-platform. It works on Windows, Linux, FreeBSD, Solaris, OS X, you name it. Really strongly recommend it. Personally, I tend to do a lot of packet capture using TCP dump at the command line. And then what I do is once I've done that from a box that's somewhere in the network, I then download that capture information into my PowerBook here and run Ethereal, and that way I can use the nice graphical tools. They have all kinds of tools. For example, you can trace TCP sessions throughout a large capture, so it really helps you visualize what's going on and get to the bottom of something. So we have a lot more information here towards the back here. We really want to urge you to move forward with this stuff. We talked about our 6-phase methodology. The first phase of the 6-phase methodology is preparation. Well, as a matter of fact, we're all already embarked on that. Everybody in this room, by coming to NANOG and by coming and listening to this tutorial and participating in it, you've already embarked on the preparation path. So now we just need to continue down that preparation path and take all the various things that we've talked about, pick one, and start working on it to deploy it throughout the network. We need to document it as well so that we share the knowledge. We need to take this information and disseminate it to our peers so that we're not the sole gatekeepers here, and so that other folks know how to make use of these methodologies and these tools as well. It's really important to have a CERT at your organization. It's really important to have an OPSEC team. Get on the NSP SEC mailing list if you're not already. You can check first within your organization to see if the appropriate folks are already on there. Same thing for INOC DBA. There's a directory at the PCH website. You can actually go and look up and see what organizations are on INOC DBA and who from those organizations are already there. Know how to get in touch with your various vendor security team. For example, at Cisco, we have the CERT, we have security alert at cisco.com, and then you can go to www.cisco.com/security to get all this kind of contact information. Your other vendors have similar types of resources. You need to make sure that you know how to reach them as well. Be prepared. Have this stuff written down. Have a plan. Have tools set up and ready to go so that you're not scrambling around in the middle of an incident trying to re-engineer your network. Before you go and get really excited and talk to all your peers and your customers, make sure that you have all this relevant information about your own organization first. It's always good to start inside the organization and then work your way out as you gather all these things and work out the policies and procedures and get the communication plans in place and those kinds of things. Make sure that you have all the relevant email addresses, phone numbers, cell phone numbers, pagers, web pages, and all of that. And in addition to having it stored somewhere electronically, make sure that you have a hard copy. Because if the network's down for some reason, if there's a big problem, a big DDoS attack, a worm outbreak that disrupts the network, it's important to at least have a piece of paper where you can try to call somebody on a cell phone or get a hold of someone via another method. So make sure you have hard copies printed out, kept updated, and distributed to the appropriate members of your OPSEC staff. Again, with the OPSEC team, make sure that the OPSEC team not only has access to all the resources and tools and communications plans and escalation paths within the organization, but that you know who your colleagues are with other service providers and with your vendors as well. There are canonical, email addresses that every service provider should respond to. Have you registered your NOC, the canonical NOC list there at puck.nether.net? Go and check. If your NOC's not in there, please go and add it in there. RFC 2142 defines the various email aliases that all service providers should have for customers to reach for various types of purposes. It's really important, and we're seeing a lot of customers, enterprise customers especially, are really insisting that from their service providers, from their vendors, that they have a /security web page off the root of the domain. So here at Cisco, for example, it's www.cisco.com/security. It's important that you ensure that all your vendors make use of this, so it's a quick thing to go. You don't really have to remember it. If you're looking for information in a hurry, that you can get there. Make sure that you have all the incident response contacts for your vendor, 7x24 contact information, pointers to all the various BCPs that they support, their security policies, etc. Same information for your customers. I mean, I can't tell you how many times, I've had to deal with bad stuff happening, originating in a customer site, and I didn't have the contact information to get a hold of them to make it stop. It's very important that just as you have all this information from your vendors, you have it all from your peers, your upstreams, your downstreams, other service providers, that you have the same level of documentation kept as up to date as possible for your customer, so that you can get on the phone with your customer, reach them via email when something bad is happening, they start pummeling your network. Really important. Remember to communicate. It doesn't help to have all of these various RFC compliant email addresses set up if nobody is actually reading the email and responding to it. Auto responders are fine. Hey, okay, here's an auto response. We got your email. We'll deal with it. But then deal with it, right? If you have the capability of doing so, fix it so that these various RFC compliant email boxes maybe have the ability to automatically open a ticket in your ticketing system. That way it doesn't get dropped on the floor. There's nothing more frustrating than going and identifying an abuse at email address and sending information there and then never getting a response. The CERTs, the various CERTs. The original CERT, of course, was CERT CC. The names vary. Sometimes you'll see them called ARTs for Incident Response Team or CCERTs. Start with CERT.org and FIRST.org and work your way down there to find the ones that you're interested in. Collect all the information again from your peers. Make sure you have all the contact information, that you understand the security policies of your peers, of your vendors, of your customers. One thing that you don't want to do is be overly dependent on any of your vendors. The vendor should be your partner. The vendor should be able to adequately explain how his equipment works, provide you with BCPs and that kind of thing, and work with you as a partner in dealing with security incidents, but don't count on the vendor to run your network for you. He's not going to have the same knowledge of your network, your traffic, your customers, your peers that you do. So don't be overly dependent on your vendor. There are certain responsibilities that you need to make sure that all of your vendors live up to. You want to be able to have 24/7 tech support. You should not expect the vendor to run the network. Make sure that your vendor is a member of FIRST. Really key. Put that on RFPs, that your vendor should be members of FIRST. That way you know that your vendor is a member of at least one body knowledge and information sharing, so that when there are large internet-wide security incidents or other things, that you know that there's at least vendor representation from your vendor in the first team. All the rest of this is just a bunch of links going to various sources of information on some of the topics that we discussed. Again, the presentation is available for download. We'll have an updated version with a few typos fixed shortly. It'll be made available in PDF and PowerPoint format. Initially, we'll see if we can get an open office format presentation there as well. This is open source material. You can take it back, incorporate it into your presentations to use within your organizations, to talk to management, etc. I hope it was useful. You've been a great audience. Thank you very much.